What's up, gangsters? How about episode 9 of the Rough Inferior Adventure? And yes, it is actually episode 9. When I posted episode 8, somebody pointed out that there was no episode 6. And I was like, what? I know I made episode 6 because it had a bunch of stuff in it about soldering. And yep, sure enough, after nearly 400 episodes, I finally just straight up forgot to upload it, as I discovered, much to my horror, when I went back and looked in my folders. So anyway, episode 6 actually exists now, and this is in fact episode 9. I don't want to waste too much time with the preamble because it's long. It is really all about the rear wheel and the fact that I did go ahead and choose to design and print a replacement for the tire that comes in the kit. So there's a bunch in it about 3D printing and designing and figuring a fit solution. But I also do an overview of how I did the tire in Fusion. So if you want to skip straight to that, I think, go to like minute 45 or something. And the overview of the CAD modeling is right there at the end. Let's get to it. Okay, it's a few days later, and after some abject procrastination, I got back to messing with this wheel, which, yeah, it's just ugly. And this is the best it's going to get. But my little fixture, truing stand, whatever you want to call it, was a good idea. It's really helped a lot because basically what I ended up doing was just tightening the axle enough that it wouldn't move and just eyeballing the parallelism of the rim with the sides of the truing fork and just shoving on it with my thumbs to get it as straight as possible. And then I added these screws so that I would have like a quick visual reference for both the straightness and the run out. Didn't do a great job with them, but they sort of serve the purpose. And, you can see kind of, I'm not too bad. I'm within about a 0.5 millimeter on straightness. That's about the worst that it gets right there. And about the same on run out. And with run out, there's really nothing I can do. The rim is just, blatantly out of round. The only thing that's really going to matter is if it looks straight in the swing arm and everything fits. And one problem that I have already discovered with that is that I can see when I rotate this around is that these bolt heads that are sticking out of the brake rub against the inside of this fork. This is just another, frankly, silly design mistake on this kit. There should be enough of a boss sticking out of this side of the brake to allow those things to clear, because the same thing is going to happen, and I've noticed that already, when I stick it in the frame. And it makes getting it in there a bit of a hassle. So I'm going to see what I got to do to deal with that. That's part of what's kicking it over when it's right there, because you can look in there and you can see those bolt heads are pushing up against this side of the little fixture. So I think I'm probably going to end up knocking those completely off and I don't know, replacing them with something else like I did on the engine cases. I think I'm definitely going to do that on the sprocket side. There's 3 bolt heads there. I don't know. But there's another issue that this uncovered. If you look at this, I think I mentioned this before. It's not apparent right here. Look at the face of the brake drum compared to the rim. Looks pretty parallel there. If I rotate it around a bit, though, it gets starting to get a little wonky. It's got a little bit more at the bottom, and it's really apparent right there now that I've rotated that gap around to the top. Not parallel. And I'll take this out of here and I'll show you the reason why. Okay, this should be pretty easy to see. I can see it with my eyeballs. Look at the face of the hub where the axle is sticking out right there. It is not parallel with the rim or the sprocket. It may be hard to see, but it's definitely a thing. I can squint one eye and sight along the rim, and I can pick it up pretty clearly that this face right here is not parallel to any of the other surfaces that it should be. And that's pretty frustrating because, I don't know how it happened. I'm embarrassed that I missed it, but you can see this thing screws onto the rest of the hub with these two screws, and it's the sort of thing where you should be able to assume as you're putting it together that everything is parallel. That's the assembly right there. It's just a stack of parts, and there's just no excuse for any of them to not have parallel faces. That even though there's half dozen parts there in that stack up, that should not matter, and that's just a fail. But at this point, it's too late to really properly fix it, and I'm going to have to just sort of kludge some kind of a solution. I think that's probably, wow, it's really apparent from that angle with the axle out of there. Maybe you can see it. It's pretty bad. Camera lenses being, as they are, make it where it's kind of harder to see on camera as I'm looking through the viewfinder. But anyway, I think that probably I am either going to have to, like maybe grind a little pocket in the backside of this, or maybe take some of this lip down. I don't know. I'm going to have to just, it's going to be a fuck around and find out kind of a thing. None of it's really going to show in there. That's also why part of my fix for the wheel was spooging a bunch of my new black Starbond CA in there, because it's perfect for that sort of thing. It's runny enough that it'll go where you want it to go, but thick enough that it'll provide some structure when it cures. And none of that's going to show. All that's going to be painted black, and it's going to be in shadow, and so no worries there. I'm just going to have to do the best I can with it, kind of like everything else on this silly thing. Okay, so I think I've got the wheel about as good as it's going to get. And I'm sure some of you might have been watching that previous clip and were thinking, idiot, the outside part of the brake drum isn't supposed to turn with the wheel. Yeah, we know that, but the fact is it was, and I just wanted to point out that was what I thought was causing some of the wheel kicking over to one side. And really there needs to be some clearance between the outside of the brake drum assembly and the frame, and that boss in the middle there should be a little taller. I'm not, changing my position on that. But anyway, this is the condition of the wheel now. To fix this, I basically just decided to file a little bit off the high side of the hub. That was the simplest place to start. And I think that's enough because it's not really showing it here because I've got this toothpick stuck in there. But I've got it where the hub will sit square. Or the brake drum will sit square. So anyway, the reason the toothpick is in there is to stop the aforementioned rotation of that while I spin the wheel. And you can see, I don't know if I can hold this thing steady enough to where it's really gonna show on camera. I don't know. Maybe. Oops, going the wrong way for my little wooden stop. It's hard to get it at the right angle for the camera and be where I can see it, but you can see there what the run out is, as well as the crookedness, and there's just nothing that I'm going to be able to do about that. I think I've got the wheel about as good as it's going to get, and as long as it looks okay in the frame once it's all assembled, that's all that really matters. Okay, so this is the question that's been on my mind for quite a while, and that is whether or not the wheel will go in with the tire on there and clear the tip of my semi-bobtail fender, and you can see that it will not. And so what I have to hope, and I think this is probably true, is that the axle will go through the dropouts from the side once the wheel is already in there. And that's actually the way that modern motorcycles work, at least every modern motorcycle I've ever turned a wrench on, because these dropouts are not open. It's typically a closed slot, and you don't have any choice but to put the wheel in and then put the axle in from the side. And this will do it. I could have answered that question a long time ago. So that's good. That's a huge relief, because that means that I can put the wheel in there and then put the axle in. Maybe. It's pretty tight. I think I'm going to have to, I don't know, there's like barely any slop there. And this is part of the problem with scale, because the thickness of that rear fender, whether it's, got my little, semi-bobtail tip on it or not, means that the wheel just barely sits in there with the axle hole all the way at the front of the dropout. And I designed my chain for that, for the wheel to be in that position. So I think I'll be okay with that. But it's all very close. You just don't have the adjustability that you do on the real thing. And with the imprecision of the way this whole thing has gone together, it's a real challenge. But one of the things that I think I want to do, that I've been contemplating a lot, is whether or not I'm going to use the kit tire or design and print my own. This tire is pretty cool looking, pretty authentic. I like the tread. It actually went on here fairly easily. I was able to just put it on with my thumbs. No tire tools necessary. I couldn't even tell you how many real life motorcycle tires I have put on with my hands and tire irons. And it's one of those things that when you race motocross, you get pretty good at it unless you enjoy taking your wheel to the motorcycle shop and paying them to do it. But they were never as easy as this, where I just pushed it on there with even my weak thumbs were able to do it. Anyway, my only issue, I have two issues. One is that these vinyl tires have a bad reputation in the scale modeling world for disintegrating over time, having bad chemical reactions with adjacent parts, and it's typically styrene next to molded vinyl, and this is metal. But and this tire's 7 years old. It's been sitting in the box, but I don't trust it. I'm building this thing to last forever. Like, I'd like to believe, and this is stupid, obviously, but I'd like to believe that, somebody might find this thing in a, far future antique shop on a, some other planet and be like, damn, this is a motorcycle model built 400 years ago by some dude on Earth. I mean, yeah, obviously stupid, but okay. Allow me a little bit of silliness and just know that I want to build this thing to last forever. It's part of why I'm using solder everywhere I can instead of just super gluing metal parts together. And I just don't trust this. Now, are 3D printed parts going to be good forever? I mean, we don't know, we don't know. We've got, people using resin printed landing gear on 1/48th scale model aircraft that are absolutely gorgeous. And I look at them and I'm like, the time strength of materials thing is a real issue. And I don't know that those landing gears are going to keep their shape forever. But this tire, not the same. There's no leverage on it. It's just going to, if this model is sitting on its wheels, then there's no reason to believe that the tires would ever deform. Now, it's probably not going to be sitting on its wheels. I have a plan, but that's a whole different topic. Here's the other reason, and maybe the more important reason, that I don't really want to use this. I am going to do some light weathering on this thing. I've decided as I've gone that I want this to look like an in-use motorcycle. Whether that's in the 30s or the 40s or the 50s or whatever, it's going to have a little bit of grime and a little bit of road dust. And I want to be able to paint the tire accordingly. And these vinyl tires and paint, no bueno por caca. They do not like each other. They don't mix. And so for that reason, I'm thinking about using a resin tire. Now, I have two challenges there. One is a resin tire ain't going to go over the rim in one piece with my thumbs or anything else. That's a problem. That means I got to split it. And that's okay, because I feel like that I could design it such that the split is relatively easy to deal with. Out here in the open part between the rim and the tread, I should be able to satisfactorily fill and cover that up. But the other issue is the out of roundness that I've mentioned several times. With this soft vinyl tire, no big deal, nobody cares, nobody sees it. But with a rigid resin tire that's in two halves, now we have a bigger problem. So I don't know if I can make it look good. I think that the only way to figure that out is to just fuck around and find out. So probably make a carcass to test how the fit is with respect to the roundness before I spend any time designing a tread and see how that's going to work. That's probably what I'm going to do. If that works, I probably honestly will go with a different tread for two reasons. One is just pure vanity, so people will look at it and go, oh, that's pretty cool. That's not the tread tire. That must be a a custom-made tire because the tread's different from what's in the kit. But the other reason is that, like any motorcycle, even in the 30s, there were different tires available that had different tread patterns, and I think some of them are more interesting than just this one. And so, yeah, gonna probably look at doing that. So, yeah, gotta decide how to proceed from here. Okay, so I decided to just go ahead and get down the road with at least starting on the tire thing. So, I've got a couple of things going here. I started with a pretty simple solid in Fusion 360, and I think I might actually go through the process of creating the tire, not as a complete CAD tutorial, but just so you guys can see how that's done. Anyway, as you can see, my decision is to split the thing across the diameter, and I really don't have much choice because this is kind of like an actual real-life rim in that it has a well for the spoke heads and all of that, and it's not constant diameter, and so any tire that's not flexible, like this kit one is, absolutely will not go over the lip of the rim. So I don't really have much choice. And I really do think this is the best because I'm gonna have two very short seams to deal with, and one of those is gonna be probably completely hidden underneath the fender. At least I can rotate the tire so that it is. The other seam will be visible, but it'll be down at the bottom, not a big deal. And I am going to want to put details on the sidewall that are better than the kit tire. It's got Dunlop on there. And I'm going to want to do all that. And I don't want to have to work around that while I'm dealing with said seam. And any sort of annular seam, like some car model tires are split at the edge of the white sidewall. And that's great if your rim is constant diameter and you're not worried about having to deal with said seam. So anyway, I think this is really about my only choice. So anyway, this was my first try and it was not too far off, wasn't too bad. But as usual, it takes multiple tries. My rule of thumb is that it's going to take 3 tries to get something to fit properly. So anyway, here's my second print, and this is kind of a moment to just talk a little bit about some 3D printing things. Some people may look at this and go, well, first of all, what happened right there? Why didn't those supports print? They printed successfully on the other places. They printed successfully. I ran this exact same setup on the first one, and the answer is, dude, I got no idea. Sometimes shit just happens. 3D printing is a process that runs on junk technology and junk equipment at a place somewhere between magic and total chaos. At least resin 3D printing does, or consumer grade resin 3D printing. And sometimes shit happens is the only real explanation, and you're just never going to print your way out of the problem. Kind of like the little bubbles I talked about earlier. And, for now, it doesn't matter because these are just test fit parts, and I don't really care about that. If it persists, I'll have to figure out what's going on, but that may be just a matter of moving it around on the plate, putting heavier supports in, because these are all light supports, maybe increasing exposure, who knows. But the bottom line is, not worried about it here at all. As regards those aforementioned bubbles, got some of those. Random right there on the top of that one, but not the other one. Well, actually there is one right on the side there. Again, not worried about it. Now, as I show you that, you can also see the layer lines, and this brings up the question of orientation. Because I'm sure some of you guys are like, why did you orient it that way? Why didn't you angle it? Because there is this persistent trope in 3D printing that you should always angle your parts. And I'm not going to get into all of the reasons or go into great detail, but the bottom line is that there is no optimum angle, especially not if somebody tells you that you should calculate it for each, for your particular machine or your layer thickness. That's a separate video, but it's nonsense. The fact is that the only correct orientation for a 3D print is the one that presents you with the most optimum use case or aligns most optimally with the given use case. In other words, it all depends on the geometry of the part and how it's going to be used and what's most important to you. So what's most important with this tire is going to be, well, I want it to be round, ideally. I want it to be round. Now, is this orientation the most optimum to make something round? Generally, no, because you're making something in layers and you're approximating a curve with a bunch of straight lines. And so there's always going to be a little bit of out of roundness. But you're going to see that a lot less on something that's larger diameter than you do something that's really small. And you can see the reason why right there on top when you look at those layers. Each of those flat layers represents a smaller and smaller portion of what is supposed to be a curve. If it were something the size of these little spring spacers and I printed them laying down, you'd notice the out of roundness much more. And that's why I printed them standing straight up, because that's always going to be the most accurate way to get a circular feature. But you can't always do that. I could have here, but then the negative is that I'm going to have more of these layer lines to deal with all the way around the circumference of the tire, and going back to having to sand in and around details like the the branding and the tire size and all of that. That's going to be problematic. And when I print it standing straight up, the sidewall surface finish, even at a 50 micron print, is really about as perfect as it's ever going to get. So right there, I have to compromise between accuracy and surface finish, and it's really not much of a compromise because accuracy is just not going to be much of an issue on a circular thing that's this large. So I don't want to lay it down flat like this. So why didn't I angle it? Well, why would I? Okay, the only advantage is that it's going to take less time. This is a 50 micron print. It took about 3.5 hours. I ran it at night. I don't care. I wouldn't have cared if it took twice as long. So for me, time is never a good argument for angling a part, laying it down. The other rational reason that you might want to lay a part down is if it decreases the size of the cross section and you're having a hard time getting parts to stick to the plate. Well, I'm not. And the fact is that if I angle this, the cross sections actually are going to get bigger, so that goes out the window. So no good reason to angle it. Now, some people will say that you'll get better surface finish if you angle a part. Well, maybe. I mean, obviously, these sidewalls are straight up and down, and the surface finish is perfect. And you can see that with this changing angle of the circular surface, that there is no perfect angle. The surface finish is perfect down here where it's close to vertical, and it gradually becomes more apparent that you can see the build layer lines as you work your way up. But it isn't until you get to a really shallow angle that you start to be able to see those up there at the top. And this emphasizes a fundamental truth of resin 3D printing. Layer thickness has far more to do with surface finish than orientation. You can see that if I reduced these layers from 50 microns to 20 microns, that there'd be 2.5 times less space between those edges. It's automatically going to become a smoother surface. If I go down to 10 microns, now there's 5 times less space between those lines. And again, each layer is much thinner. It's going to be much easier to deal with that. But the truth is, I really don't have to care, because when this is all said and done and I have a tread on here, that's not going to show very much. It's going to be super easy to prime it and sand it smooth. And if necessary, if it was really, really, truly an issue, then I could change the orientation. Pop this off of here. Okay. I could change the orientation from this to something more like this, because even though that's going to take a lot longer, it'll bring those layer lines up near this joint that I'm going to be either dealing with or hiding anyway. So kind of can kill two birds with one stone. So I could end up doing that. At 20 microns, that's going to be, and then I will end up probably doing it at 20 microns, because for the details on the sidewall, I want to really make sure I get the best fidelity. And at 20 microns, that's going to be probably like a 10, 12-hour print. Again, I don't care. I'll just run it at night. So all that being said, now that we've kind of talked a little bit about the printing side of it, let's take a look at the part itself. I pretty quickly figured out that I was going to need a little bit of a well inside the tire because of those spoke heads not all being flush. So that's why I've got that. And you might say, well, why didn't you just make the whole tire hollow? It uses less resin, weighs less, whatever, and I could have. That's not wrong. But I just don't feel the need to. I don't care much more about how much resin I use than I do about how long it takes. Because I find that that's just, it just kind of all comes out in the wash. So anyway, there we go. That's my first attempt at looking at how it fits. And in terms of roundness, that at least looks pretty good. And let's flip it over. Let's see how it is in terms of width. That fits down into the rim pretty well. Got some clearance. I want to have kind of a loose tolerance because this rim, as we know, not very round. And I'm going to need to be able to wiggle the tire around a little bit to get the best look all the way around. Like you can see, there may be a little more gap or whatever on one side. I want to be able to disguise that as much as possible. So anyway, that's the plan, and I'm going to pop this other side off of here, see how that fits, and once I'm satisfied that this basic carcass has the right dimensions, then I'll go and start adding tread and other details. Okay, I just have to show you guys this because it's such a perfect example of why so much of what we do with resin 3D printing should include the caveat "in theory." Because when I made this tire carcass in Fusion, all I did was do a revolved solid and then split the body. So the split should have left me with two exactly perfect hemispheres, in theory. And the joints should have been exactly coplanar, in theory. And there should have been no gap, in theory. Yeah, so much for the theory. So that's going to be an issue. I'm going to have to do some fucking around and finding out to figure out how to deal with the fact that, yeah, things don't always work out as you think they will in theory, and I don't want to have to fill a gap that's that large. Here's the other thing I forgot. Some of you guys may have been like, dude, why are your parts still stuck to the build plate? Well, if you haven't watched any of my 3D printing videos, you may not know this, but I wash, and when I cure, I do everything still on the plate for a couple of reasons. One is that it's easier for me to handle the whole part. I can't wear gloves with my stupid lobster hands. And so I don't want to fuck with parts that are covered with uncured resin. And so, and dealing with getting them off of the plate in that condition is just messier. And the way I do it, I might get a little spot of resin on my hands because I take the thing out of the printer, put it on a drain tray. Once it's drained, I put this whole thing in the washer. I do a 2-stage wash. Once I take it out of the wash and it dries, it's clean. I can deal with it. I say if I cure because I don't always do that. With the Anycubic wash and cure station, you have to take the washing vat off and put the turntable on to do the cure. And honestly, yeah, I'm lazy. But the truth is, there's no need to. These parts are just for test fit, and curing them is just a waste of my time. And then there are people who are going to say, oh, dude, you should never touch uncured parts. Yeah, look, come on, that's just nonsense. Even though these are like 90% cured, there's nothing liquid on here that's going to get on your hands or make you grow a third nipple or whatever. It's just simply that the cross-linking that turns this into a solid is not 100% done. There are still a few molecular chains in there that remain to be connected, and that's all the post-cure is really doing for you. So, yeah, not a big deal. And then the big objection is that, well, how are you going to get them off? Isn't it hard to get them off? Nope, not at all. Even if they were cured, with this scalpel, it is super easy. The trick is that the scalpel is so thin that it basically just slices underneath. These are actually kind of crispy, probably got some sunlight. Sitting here overnight on the workbench. Anyway, this is about as difficult as it ever is to get it all off of there. Not a big deal, and you can see that my build plate is relatively unscathed. So, that's the way I do it. That's my story. Okay, here we go with round 3. Now, you will see a lot of people say a lot of silly things in 3D printing groups, and one of them is, you should never print directly on the plate. Yeah, really? Why not? Yeah. So sometimes, rarely, but sometimes it is actually the best strategy. And I decided that on the chance that this issue was caused by the thing being able to squirm around somehow on the supports, that I would try this and see what happened. I mean, it was a super easy thing to do. And as you can see, I've gotten into the fun part. I wanted to see how the tread looked. So all I did was eliminate the supports underneath each end of the banana and lower it until those faces were directly on the plate. Now, one thing you'll notice is that there's a little bit of an undercut there. That's pretty normal due to an issue called squish and various other things. You'll hear some people refer to it as elephant's foot. It's a thing. It's a whole other video, but I've counteracted it by putting a negative 0.5 offset on my burn-in layers, and so that's why I have a little bit of an undercut, which is fine. If that's the biggest problem compared to this, I'll be happy. So anyway, let's take some measurements. My notes tell me that the tire on the outside should be 73 millimeters. And when I measure the OD of this thing, it's, let's see what it is. It's a bit big, but not like out of the question. You know, nothing that would cause me to think that's what accounts for this. Let's go the other direction, see how we're looking. Yeah, I mean, they're, you know, again, almost half a millimeter big. Look, you know, for something like this, half a millimeter is about what I would expect to be within, you know, resin printing tolerances. You know, resin printing is not as perfect sometimes as we'd like to believe. Let's see what our diameter is down here at the base. 72.95. So that's great. All right. Let's do the other one. That should be the same, but 72.88. I mean, that's really pretty good. Okay, so we're 0.1 millimeter, basically 4 or 5 thousandths of an inch off across nearly 3 inches. So not bad. Now, here's the thing, though. Let's see how it measures in the vertical direction. 36.3. Siri, what's 36.3 times 2?
It's 72.6.
So we are about a half a millimeter small in the vertical direction. Now, if that's true on both parts, then in theory, we would have about a 1 millimeter gap. This one's 36.4. Siri, what's 36.4 times 2? Well, wow, she decided not to help. Now, Siri, what's 36.4 times 2?
That would be 72.8.
So that's a little bit closer. Maybe my measurement was better. Let's take a third one. 36.4. So we're only about 0.2 millimeters off in the vertical direction. You know, so I feel like I can conclude that the dimensions are pretty good here. But let's see what happens when we get these off the plate and put them on the rim. And you can see that wasn't too difficult at all to get those to release, even though those faces were printed on the plate. And you can see they are perfectly flat, which is great. Just out of curiosity, let's do this and see what the diameter says. Easier said than done, like most things I attempt to do on camera. 72.7. I mean, yeah, it's a bit small, but again, 0.3 millimeters across 73 millimeters. It's hard to be mad about that. But here's the magic moment. Let's see if it's done anything to resolve the actual issue. Okay, so there we go. I have still got the exact same gap over here. And I think then that the only conclusion is that I'm going to have to increase the inside diameter a little bit, which is, yeah, no surprise. Pretty normal stuff for this type of thing, that it takes a few tweaks. Well, it took a few tries, but that's okay because while I was getting the fit dialed in, I was also working on creating the sidewall details. Hopefully you can see those in the CAD model, and that was pretty cool. Turned out pretty good. So this is my final print. I think it took me 5 prints. I don't know. But what it ultimately ended up being was, like I said in the last clip, just a matter of dialing in the tolerances because, I had a nice perfect fit to start with, and that sort of led me to believe that maybe something was wrong with the overall shape of each piece. But the fact was that it just needed more slop because this rim is like a 0.5 millimeter out of round. So once I did that, I was able to get a pretty good joint. When I put it on here in a test fit, it was like that on both sides. But then when I put it back together with glue, of course, and with it oriented in exactly the way I wanted it, because I had a chip in the rim right here, and I figured, well, if I'm going to hide all that under the fender, I might as well hide that chip too. Anyway, then I had about a 1 millimeter gap with it flush down here. This is the one that's going to show, so I made sure that was squeezed shut. Not a big deal. And I used some of my black super glue, and so I have a pretty nice tight joint. Now you can see here I've already been working on this one, and what I'm doing there is what I feel is the best technique for dealing with gaps in printed resin. Just like with polystyrene, if you can stay as close to the base material as possible, you're better off. So I have a little cup of resin here from the machine, and all I'm doing is just applying a little bit of that to the joint. Just enough to fill it in there. I don't want to have to do any more sanding than necessary. And it flows nicely, so that's all good. Once I get a layer of it in there, then it's just this UV flashlight. And this stuff starts, it takes a set almost immediately, just like it does in the printer. And so this is a super effective and easy way to fill a gap like that. And when it's time to clean all that up, it'll be just the same as dealing with the original material. So should be pretty straightforward. I'm going to take this whole thing now and put it in the Anycubic curing station and get a good final cure on this part, and we'll be good to go. Now let's jump over to the Mac and take a look at what was required to make the CAD model of this tire. All right, let me just give you a quick rundown of how I built this tire. Tires can be a kind of an intimidating thing, but honestly, they're one of the things that, to me, we might be most likely to do as scale modelers, because a lot of times, the wheels and tires we get are just not great, and we want something better. So here's how this one goes. First thing is to create a basic tire carcass with the important dimensions nailed down, and in this case, I thought anyway that I knew what the inside diameter needed to be, I knew what the width needed to be, and what I want is a fully constrained sketch, and here's the key thing, that allows me to adjust those parameters without anything crazy happening. So I can change the inside and outside diameters pretty easily with these two numbers. Now, it will affect the sidewall, which you can see is not constrained because I made that using a spline. And I typically don't constrain splines. And so if I were to adjust the diameter of this, it would affect that. But it's relatively easy to readjust because I can just manually move these points around. But that spline, once I'm happy with the shape of that sidewall, is just mirrored over to the other side. Now I also have this top curve here, which right now is just or at least when I started, was just kind of an arbitrary curved segment, because I didn't care about the outside shape of the tire at that point. I was just trying to get the fit dialed in. But once I got the shape that I wanted for the outside, then I have this inset curve, and that represents the bottom of the tread lugs. So that's all set right here at the very beginning, and that's just a revolved solid, and that gets me this basic shape. Now it's time to start working on the tread. And the tread for this tire is relatively straightforward. It's just kind of this elongated hexagon. And they're all the same, or pretty close, I thought. Anyway, the first thing that I wanted to do was create the, the very first lug. And so that was going to be a sketch. And I used a canvas. If you don't know how to insert canvases, Canvi, whatever, it's this icon right here in the insert menu. And that can be any JPEG photograph. And this is one of my reference photos, which was super handy because it gave me this exact rear view of the tire. And so I've got a really good reference for how to appropriately size that tread block. All I had to do once I brought the canvas in here was make it the right size, so that the photograph basically matched the sides of my tire carcass. You can see it's pretty close. So this is how you get in the right neighborhood for dimensions. Once I had that first lug defined, then what I started doing was patterning it. And so I actually did a revolved pattern all the way around. And there's a lot of going back and forth with this. And this is one of the things with parametric CAD, is using the timeline to help you develop the model. What I did actually at the beginning is I made my first row of the center lug all the way around, so that I could figure out how many instances it was going to take to get all the way around the tire with the correct amount of spacing in between each one. Then, and that's this pattern right here. But then I came back and I made a pattern that is revolved about the axis that runs through the arc that defines this face of the tire. And that lets me get a lug on either side with the right amount of spacing and have it be equal. What I discovered then was that when I ran the lugs all the way around using the revolved pattern here, was that these side lugs were too big, which because the circumference is smaller out here. And so the gap between each one was smaller when I had the same amount of lugs as I did on the center row. So what I had to do was go back and I just scaled the two side lugs using these operations right here. Shrunk them to, it ended up being like 97.5%. And then I had to adjust their position a little bit, got them back in the right place so that they were lined up, and then I have 3 full rows. All right, so the next thing that I have to do is start developing the intermediate lugs. And the hardest part about that, honestly, was just defining the position so that it was sandwiched directly between those 2 rows. And I'm not going to go into the details, but basically it was just using some sketches and some geometry and being an engine nerd to figure out where to put that. And then once I had the correct spot on that side, I ran the pattern all the way around to check it, make sure it was good. And that's this pattern right here. Then I came back in, put in some more construction geometry. And if you don't know about construction geometry, that's this menu right here. That allows you to create datums to help you define the locations of things. Planes, axes, points, whatever you need. These are super, super helpful. All right, so once I had that in place, then I just mirrored those lugs. I went ahead and did this far outside one as well. And then I just mirrored those to the other side of the tire, and that gave me the rest of the pattern, and then went ahead and revolved that all the way around. Now I have a full set of tread lugs, but they're flat on top, which I don't want. So the next step is to draw a sketch that's based on the very first sketch, and make a revolved cut to trim the tops of all these lugs and give them the right profile. And now I have the basic tire carcass, but I still have too much of the lugs sticking out right here on the edge. And so I do another revolved cut, and that trims off the edges of those side blocks. And now with the addition of a radius on this corner in here, I have the complete tire carcass. Now, what you'll notice, one of the things that I preach a lot is that you should always end up with one single body, and that you should try as much as possible along the way to work with a single body. But sometimes not only do you need multiple bodies to figure things out, like when I was working with just 3 lugs, I really needed for all 3 of those lugs to be separate so that I could manipulate them the way that I needed to before I made them part of the overall tire carcass body. But it didn't really matter because for whatever reason, Fusion did not want to do this massive pattern as a join, and it left me with whatever this is, 400 bodies. And so my next step was to do a combined features and put all those into a single body. And I wanted to go ahead and do that, even though I know I'm going to be adding some more features, because again, I want to keep the math load on Fusion as minimal as possible along the way. And so I don't want it having to try to figure out how to combine letters on the sidewall with knobs and all the things all at once. Again, just being smart about using resources and also checking yourself along the way. Because if I had tried to combine all these bodies and I'd had some errors at this point, I would have known that I had a mistake somewhere in this part of the timeline, and I could have gone ahead and dealt with that before moving forward. All right. Now, the next thing is to begin to define details on the sidewall. And I started with the logo because that's always the toughest part. And again, not going to go into the super details about how to do this, but the basic workflow is that you got to find an SVG somewhere on the interwebs, and chances are it's going to be straight and not have an arc. And so take that into your favorite graphic design program. I use Affinity Designer 2, and warp the logo so that it fits an arc. And create an SVG, and then you're going to do an insert SVG. You get that properly scaled, and now you can see it's a bunch of separate bodies, because once I extrude all those, each individual letter and segment is its own thing. And if I turn off the overall body of the carcass, you can see what's going on there. So the first thing was to go ahead and turn that back on. Thought for a second there I was missing the A. All right, anyway, so now that I've got that, what I want to do is create a feature that is going to combine all of that stuff into its own body, because I know that once I have all these letters in place, what I'm going to do is take this body and I'm going to do a move operation right here, and I'm going to flip it over to the other side so that I've got all of these letters on both sides of the tire. So once I've got this combined and I've checked that everything is going to work, I come back in the timeline and I start adding all of the individual letters And now all I have to do is use the create text feature inside the sketcher, and it gives you the option to bend those things around an arc, and makes it pretty simple. And so I just keep doing that, get all of those letters on there, and now I have this body. And I'm going to do a copy and move, and now when I display that, you can see what my strategy was. I've got these two bodies that have all the letters on both sides, and then I'm going to take and combine these two bodies with the original body of the carcass, and then come back and do a final revolved cut that will offset basically the sidewall surface and give the letters the proper height, which is 0.2 millimeters is what I let these stick out as. And that proved to be a nice amount in the print. You got to have enough that it's gonna show up well, and like take some dry brushing if that's what you choose to do. And then I just did a split body right down the middle so that I had my two banana-shaped halves that I took to the printer, and then I just brought it into Lychee Slicer and added my supports, which was pretty straightforward. And that is basically the whole process from soup to nuts of how we got to the final print. Okay, so there you go. Hopefully that was useful. And as always, if you suffered through the whole thing, I absolutely, totally, completely appreciate it. And I wish you all much love in this holiday season.